Example 4. Evaluate the following primary trig ratios using a scientific calculator. Round your answers to 4 decimals. This is just to make sure we can sub in and use a calculator to find values of sine, cos, and tan. Now when you're doing this, make sure that your calculator is set to degree mode. At the top, hopefully you can see a little D or maybe the word DEG. Your calculator can be in different modes. Make sure that it's in degree mode when doing this. Now, depending on what type of calculator you have, you might have to put this in a different fashion. Most calculators, you can just find the button that says sine on it, hit that button, and then punch in 60 and hit equals. That should give you a value of, when rounded, 0.8660, and then some more decimals, but that's the rounded version. Now, if that doesn't work, you might have a different type of calculator where you first have to put in 60 and then hit sine. Decide what type of calculator you have. That's the order when subbing in a trig ratio. Try it for cos of 25 degrees, and you should get a rounded 0.9063. And tan of 64 degrees should be approximately 2.050. Example 5. This is a full question. Find the missing length of P. Now looking at triangle NPM, or triangle MNP. I have the fact that it's a right angle, or a right triangle, because N is a right angle. And I'm given that the angle P is 60 degrees. Now to find P, the angle of 60 degrees is the angle we are going to be working with. Now we have 60 degrees as our angle, P. We also have the 225 feet. That's the hypotenuse length. I'm looking for the side lowercase p. The first thing to decide is which trig ratio to use, sine, cos, or tan. Now from angle P's perspective, I have information on the hypotenuse, and I need to find the opposite side, because P would be opposite of angle P, that's 60 degrees. So I'm working with the hypotenuse and the opposite. Which ratio should I use? Now SOHCAHTOA is helpful for this. The ratio using the opposite and hypotenuse is sine, because with SOHCAHTOA, sine is opposite over hypotenuse. So first let's write the equation. Sine theta in its general form is equal to opposite over hypotenuse. Now I can begin filling in values. The value of the angle theta, or in this case angle P, is 60 degrees. And opposite over hypotenuse, well, opposite is what I'm trying to find. That's the value of P. The hypotenuse has a length of 225 feet, so let me fill that in. I have the equation sine 60 degrees is equal to P over 225. That's feet. Now solving for P, I have to do some rearranging using reverse BEDMAS. I'm dividing by 225 at the moment. To get P by itself, to isolate it, I should do the opposite of divide by 225, which is multiply by 225. If I multiply by 225, that 225 can be brought to the left-hand side, and P is now isolated by itself, which is what we want. Finally, sub in to a calculator sine of 60 degrees and multiply that by the 225 degrees to find the value of P. Now BEDMAS says we should do brackets first, so I would recommend first on your calculator punch in sine of 60 degrees, hit equals, and then multiply that by 225. Our answer should come out to be 195, and that is now a length again, so that is in feet. The missing side length P is 195 feet. Example 6. Solve each equation using inverse trigonometric functions. Now there's two ways to use trigonometric functions, straightforward or taking the inverse. The inverse is used when we're trying to find the angle itself. If you look usually above the buttons on your calculator for sine, cos, and tan, you see the three inverse buttons, which look like sine and then a small superscript -1, cos -1, and tan -1. That's just the notation for the inverse trig functions. These are used when given a trig ratio, such as, in example 6, tan of an unknown angle theta is equal to a value. In this case, that value is 1. So we will use inverse trig functions to solve tan theta is equal to 1. Now when we're looking for the angle, as is the case here, we will use the inverse trig function. To punch this into a calculator to find theta, we hit that inverse tan button. It's like doing the opposite of taking the trig ratio itself. When we're solving using algebra, we use inverse operations. When we're solving trig equations using algebra, we use inverse trig equations. In your calculator, try tan to -1, so that inverse value, and then the value itself of 1. Now, if you're doing this on a phone calculator, you might have to go into the second function options menu. It's located in there sometimes. What is the tan inverse of 1? If you put it in correctly, you should get the value of 45 degrees. Try it for sine of theta is equal to 0.8660. To solve for theta, we need the opposite of sine, or the inverse of sine, which is sine inverse. So sine inverse of 0.8660. Experiment until you see the correct way to put this into your calculator. After doing this and hitting equals, you should get a value of 60 degrees or pretty close to 60 degrees. A final example is example 7. Solve for the missing angle A. I have a triangle that's been rotated a little bit. It's a little bit harder to see where my opposite, adjacent, and hypotenuse sides are. Well, the hypotenuse is always the longest side. That would be the side connecting A and B, or just side lowercase c. I'm looking for the missing angle A. So my reference angle is A. That would be theta. And you can see that there's a little curve drawn in for us. So between the 1.3 centimeters and the 2.5 centimeters, the 1.3 is adjacent to angle A, and the 2.5 centimeter side is opposite of angle A. So I have information on my adjacent and my opposite. Should I use sine, cos, or tan? Well, look at SOHCAHTOA. Sine uses opposite and hypotenuse. Now, it's not very helpful because we don't have the hypotenuse. Cosine uses adjacent and hypotenuse. Again, we have adjacent, but we don't have hypotenuse, so let's not use cosine. Tan uses opposite and adjacent. We have both of those. So we choose to utilize tan and start just with the general equation for tan of theta, which as always is opposite over adjacent. Now in this case, they're asking us for A, so we'll use A instead of theta. The opposite side to A is 2.5 centimeters divided by the adjacent side to A, which is 1.3 centimeters. Now we actually divide those out. On a calculator, what is 2.5 divided by 1.3? It should be the decimal 1.9231, and that's rounded. Now I have tan A is equal to that 1.9231. But I would like the actual value of the angle A. And for the angle, we use the inverse trig ratio. Now you're using tan, so we'll be using the tan inverse button. Tan inverse of this decimal, 1.9231. On a calculator should give me around 63 degrees for my answer. So step 1, identify what sides you have and what ratio you should use. It's tan in this case. Step 2, sub in your values. Opposite over adjacent is 2.5 over 1.3. Step 3, actually do that math, divide them out to get a decimal. And then step 4, because we're looking for the missing angle, we use the inverse of the trig ratio we were dealing with. We use the tan inverse in this case. A final answer of 63 degrees. And you can always look at the diagram after and think, is 63 degrees an appropriate measure of that angle A? Yeah, it's a reasonable estimation. It's not going to be exact in the diagram in the drawing, but it's not an unrealistic final value. That's it for 1.1. Below on the page there are the practice questions. Try those out. Below those are not only the answers themselves, but the full solutions in case you get stuck. Good luck.